Hi everyone, my name is Max. Today I will present you about the hydrogel encapsulation to enhance the bacterial diagnosis of colon inflammation. This paper was published on the Biomaterials journal and approved at July 2023. First, let me introduce about the colon inflammations or the colitis disease. Colitis disease is inflammation of the inner lining of the colon part at the long intestine. This disease was caused by many reasons, such as using some drug treatment, colonoscopy for detecting colon disease, and biopsy can disrupt the inner intestine layer, affecting the colitis. Also, the infections of some foodborne pathogens can cause colitis too. Among all causes, gut microbiota disruption was a crucial point causing the colitis disease because host microbiota reactions in long intestines play a role important for the balancing in the body system. The patients who get colitis disease will have some symptoms like fever, weight loss, and diarrhea, for example. Adversely, although this disease seems to cause the mild symptoms, it can trigger other unfavorable disease like colorectal cancer and other past inflammation, including osteoarthritis and cholangitis. Lastly, it can lead to death. Therefore, early diagnosis of this disease is important. Nowadays, engineered bacteria named E. coli nasals 1917 is used for the colitis diagnosis by using thiosulfate as a biomarker. Thiosulfate is created in exaggerate level when compared with the healthy people. So, when the colitis is happen, the number of thiosulfate is going to increase. This bacteria was engineered by adding THSS and THSR, which normally be in the marine bacterium, Salmonella halifacensis, and GFP genes. In the presence of the thiosulfate in the system, THSS phosphorylates THSR, which then induces the transcription from the PPHSA target promoter, affecting the transcriptions of the GFP gene. Therefore, if the thiosulfate is in the system, these bacteria are going to express the GFP that can observe under the fluorescence microscope. From this mechanism, the colitis disease can be diagnosed by using the amount of the expressed GFP signal. Normally, these bacteria were added through the gastrointestinal tract and then the GFP signals were gained from the stool samples. However, using these bacteria directly by adding through the gastrointestinal tract has some limitation. First, the bacteria were transferred through the gastrointestinal tract. Bacteria cannot survive because of the unfavorable pH condition. Second is the free cells can disperse in the tract, causing the cell losing and the low signal of the GFP signal. Therefore, this paper tried to encapsulate these bacteria for outcompeting this limitation. This paper, they use arginate as biopolymer for encapsulating the engineered bacteria via two fluid co-axial electrostatic spraying device. This method based on the external dilation that the arginate and bacterial cells were mixed and then added to the barium chloride solutions by voltage of the electric pump. The results show that they can encapsulate the bacteria successfully with the species and a uniform size around 1 to 3 millimeters, depending on the added voltage. Moreover, encapsulated bacteria can be alive after encapsulation process, being incised by the fluorescence microscope and the spreading plate technique. In this study, they want to use the being in the exponential phase because it is believed that the stability and the robustness of the engineered bacterial circuits is higher during the exponential growth phase, where the continuous growth enables a steady state of the biochemical reaction rate. For example, some sensors grow in the stationary phase exhibit the increases basal activity or the leakiness compared to the exponential phase. From the results, when using the bacterial cells at the OD 600 equal to 0.1 condition in the encapsulation process, the bacteria can go inside the bead, leading to have more exponential growth inside the bead when compared with the OD 600 equal to the 1 condition. So the absorbance of the cells at the 0.1 condition was used in this study. Next, the study about the effect of the encapsulations in the thiosulfate detection. From the graph, you see that the GFP response and the M-Sherry response from the encapsulated bacteria and free bacteria was not different significantly. Further, these bacteria can be used to make the relationship between the GFP signal and the concentrations of the thiosulfate. When the concentrations of the thiosulfate is increased, the GFP signals is increased too. Afterward, because these beads were administered through the gastrointestinal tract having both acidic condition and basic condition before arriving to the target site or the large intestine, the bacterial cells have to survive as much as they can for gaining the significant GFP signal. The result represents that the encapsulation process can protect the bacterial cells when it is in the acidic condition, while free cell bacteria cannot survive through the acidic condition. Moreover, pH did not affect the morphologies of the alginate beads. After testing the abilities of the engineered bacteria encapsulated in the alginate in vitro, they tried to study in vivo or the in animal model by using this process. First, the beads were administered through the gastrointestinal tract. After 8 to 10 hours, stool was collected and disturbed in the PBS buffer. Beads in the stool were collected for analyzing the GFP signal and the viability. The results displayed that the morphologies of the alginate bead retrieved from the stool was not changed by the pH effect, being consistent with the in vitro results. Moreover, the encapsulated bacteria can grow inside beads during the diagnosis. Following, the researcher tried to diagnose the colitis disease in vivo by using these alginate beads. First, mice were given the alginate beads for 1 day. The gained beads from the stool were analyzed about the GFP signal for making the signal of the healthy condition. Then, mice got the colitis disease by adding the dextrans sodium sulfate or DSS in the water, which mice will drink for 10 days. Then, the alginate beads were administered. After a day, stool was collected and the alginate beads were separated for analyzing the GFP signal. In this study, the mice were also divided by the adverse state of the disease by using the disease activity index or DAI index. 0 score is the healthy and the 12 score is represent the worst condition. Score depend on the body weight, stool consistency, and the presence of the close breathing and acute blood interfaces. And the results show that although the healthy condition can create some GFP signal, but this signal is different from the signal gaining from the colitis disease mice significantly. Moreover, every adverse state of the colitis disease can be detected by this method. Lastly, is the discussion part. First, the encapsulation engineered bacteria E. coli nasals 1917 in the alginate beads using two fluid coaxial electrostatic spraying device based on the excitation principle was successful in a uniform size around 1 to 3 millimeters and the spear shapes. Second, the encapsulated bacterial cells can survive and grow inside the alginate beads, can survive when passed through the gastrointestinal tract, condition consisting both acidic conditions and the basic conditions. Next, the using E. coli nasals 1917 encapsulated in the alginate beads can be used efficiently as the diagnosis tool for the colitis disease in vivo by adding beads through the gastrointestinal tract and detecting the expressed GFP signal in the stool, because the encapsulation limits the bacterial dispersions and improve the viability. And last, by this method cannot divide the adverse state of the disease. Moreover, stool sample must be collected for gaining GFP signal for analysis. Therefore, it cannot be utilized as the real-time tools.